Recent calculations suggest that the unobservable universe could be anywhere upwards of 20 trillion light-years in diameter, an incredible distance. But though upwards of 20 trillion light-years is enormous, most of it is probably empty. We can reasonably assume this because of what we know about the universe we can see, which is that it's uniform in every direction, but also that observable matter is scarce. To our eyes, most of everything is nothingness. Even so, it's not as though this observable matter just happens. It isn't simply a case of it just being there. Consult any physics textbook, and we know that matter is actually lots and lots of atoms, the tiny things that make up everything in existence. And atoms are so small that even our most powerful optical microscopes can't actually see them, meaning we have little idea what they actually look like beyond predicted scientific diagrams. Nevertheless, rigorous science has proven that atoms definitely do exist, and also that they themselves are made up of subatomic particles, including protons, neutrons, electrons, and quarks. Today we know, for example, that atoms are so small and numerous that the average adult human contains roughly 7 octillion of them, which is a 7 with 27 zeros after it. It's amazing then that there are some theories that every human, that everything and everywhere, that our entire observable and unobservable universe could actually be an atom in itself. One such idea is the one-electron universe theory, which says that what we understand to be electrons are actually all the product of just one particle. With that particle, that one single electron, infinitely traveling backwards and forwards through time so quickly that we perceive it to be many. So much so that it intricately renders and shapes our entire reality. Perhaps unsurprisingly, there isn't much by way of a solid backing in the scientific community for this particular theory. But it's a starting point, and there are other similar ideas with more support. The more mainstream variation is that while all of the atoms and electrons and properties of matter do exist as we understand them to, they all amount to the equivalent of an atom in another, much larger universe. With its roots in the multiverse theory, this is an idea that science fiction writers and filmmakers have regularly experimented with, that everything we know could fit onto the fingertips of something else, that our universe is but a speck of dust on some higher plane of existence. Or we can go the other way and look inwards to imagine that all of the atoms that make up our existence actually contain whole other existences inside them. It's a mind-bending concept that's again also built on the notion of infinity. Other than being the cornerstone of Buzz Lightyear's iconic catchphrase, infinity is, naturally, such an incredibly unendingly large idea to try to wrap our heads around. But here it could be understood to mean that regardless of how large our universe is, if we accept the multiverse theory, then another universe could be infinitely larger, making us, by comparison, from the vantage point of anything in that larger universe, subatomic. And when we look around, we see that the universe, as we generally understand it at least, already functions a little like this. All the minuscule subatomic particles go on to create bigger and bigger things, until we're dealing with the largest celestial objects and the most complex known organisms. Whether it's gigantic stars in a far-flung galaxy, soaring skyscrapers in a busy city, or just that sandwich you had for lunch today. It all uses the exact same building materials. So why stop with just the biggest things we know about? Why not zoom out and out and out until, yes, even the universe is just one part of something much bigger? Until we have a true theory of everything, a theory to marry quantum and classical physics and finally explain reality, this blurring between the micro and macro levels can't totally be dismissed. After all, according to the most popular theory on its creation, the universe itself started out as an infinitely dense and tiny singularity before it expanded into energy and life via the Big Bang. So at one time, everything we've ever known really was inconceivably small. Of course, the big difference here is that the initial Big Bang-inspired singularity, no matter how small it could have ever been, would have contained all of the stuff needed for the atoms we now know about. So we can't justifiably claim that the universe, even at this stage, actually was an atom. A singularity, yes. An atom, no. Perhaps we get closest to understanding the true scale of reality via string theory, one of the more prominent candidates for a theory of everything that we currently have. There are various models of it, but the general idea is that atoms aren't the spherical objects we tend to draw them as. Instead, they're string-like objects that vibrate, and it's the interactions between these vibrating strings that account for, well, everything. The laws of physics, how gravity works, quantum mechanics, the whole caboodle. String theory has encountered its fair share of problems, though, one of which being dark energy. The issue is that while normal observable matter, the stuff that string theory attempts to make sense of, makes up only 5% of the universe, a massive 68% of the universe is dark energy. And most string theory models can't explain that. More recently, though, there have been various attempts to incorporate dark energy into string theory, one of which could turn the question at the top of today's video on its head once again. In late 2018, a team from Uppsala University in Sweden published details of a new variation of string theory, wherein our universe exists on the edge of a constantly expanding bubble. While most string theory proposals do suggest various higher dimensions than simply the 4 we currently know about, 3 spatial and 1 time, here we find that everything we know is actually a fleck on the membrane of something far, far greater. So really, who knows what's happening inside the bubble or away from the bubble's edge, or how many dimensions these unknowns could account for? But the infiltration of dark energy into our universe from the wider bubble universe could, at least according to the theory, finally make sense. Irrespective of what it means for dark energy, though, it's another version of reality which potentially pits us as an infinitesimally tiny part of something much, much bigger. Something far greater, perhaps, than we could ever even hope to understand. In this instance, with human beings serving as just one tiny part in one tiny universe on the edge of a bubble that in itself could be one part of something even bigger, we're basically a proton or an electron or a quark in the grand scheme of things. If a proton could think, would we expect it to know that it accounts for a tiny bit of a sports car? Or an electron to understand that it represents a minuscule fraction of a single blade of grass? Obviously not. But we'd now be in that same mind-boggling position. Ultimately, if the universe really were structured like this, then it would clearly shatter almost everything we thought or even suspected we knew. In fact, we would be so deeply wrong about science on essentially every level that human knowledge might never recover from the revelation. It would be existential crisis from here on out, and a race to try and figure out some all-new extra-dimensional laws of reality. It's lucky then that this is just a thought experiment, a fun way to think about things and to appreciate our place in the cosmos. Sure, our knowledge might prove to be limited, and our perspective might be off, but even if all of this really was subatomic insignificance from the point of view of something else, then why should it really matter? We're here now, so let's